Hey everyone. It's been 5 years now since I posted my last robot video of Mr. B, that tank tracked robot that's all over my channel. Uh, it's been a long time. I went down a big startup rabbit hole, became a machine learning engineer, got into computer vision. So I wanted to show my face on here and talk to you all about some code I've been working on. I'm in between jobs right now, so I kind of went down my own self-created rabbit hole. I've got some really optimized foundation models for you all, and I wanted to kind of share it. I don't. I'm gonna make more videos like this. I don't plan on editing them. I want them to be nice and raw. Um, I'll take my time. I'll try to say as little as possible, uh, and I'm just excited to share my knowledge with you all. So let me just show you all this repo I've been working on. So, like I said, I got a bit obsessed over the last few years, especially in the startup world, with foundation models, and particularly with CLIP and SigLIP, which is a new variant that's on the scene right now. And CLIP is an open AI model that's a contrastive language image pre-training a network. And the idea is that it's trained on pairwise collections of descriptions and image embeddings. And the idea is also that it's a zero-shot classifier. So, say for instance, with your pre-trained networks, usually with ImageNet, you have an 1,000 class problem, and it's kind of stuck with that unless you're fine-tuning. So, like person, dog, tree, and all these things that are not really useful to kind of industrial applications or for any kind of specific niche applications. The great thing about Clip, and the reason I got so excited about it, kind of looking to deploy things really quickly in the machine learning engineering world, is that you can give it its own context. So you can give it anything from like 3 scenarios, 3 descriptions, to like multiple, all the way up to hundreds, and it'll give you a probability sum into 0 and 1 with a softmax activation that it's any the image or the scene or the hierarchy of the frame is that specific description. What's come on the scene lately is sigmoid loss for language image pre-training, so SigLIP. I got really excited about it. I saw it out there last year. I didn't see any fast representations, so open neural network exchange representations, which is something I've been mucking around a lot with lately as well. Or over the last kind of 5 years, I ended up down that hole where I was just stuck behind closed doors looking at screens. With no open neural network exchange, you get constant folding, you get a kind of optimized graph. Any operations that can get taken out of the forward pass of a neural network get taken out. And this all happens automatically, and this all happens within the open neural network exchange runtime framework. I did a lot of work with that with CPUs, with cloud deployment, but also getting things on robots. So single board computers, system on chips, and so on. I'm going to have more videos like this out there in the world, where most of my code I tend to build it to try and get on edge devices as much as possible. I mean, there's a lot of exciting talk out there right now. There's a lot of talk about these really heavy language models. But what I'm really interested in is moving towards this world of kind of embodied AI, where we can get these really chunky frameworks or these chunky neural networks running out there mobile without any network crutches, and have a world full of kind of Disney characters around us. So, um, what I've been doing over the last week is trying to build SigLIP and CLIP and all these different optimized foundation models into one framework. All of them are open neural network exchange representations, so pre-processing, post-processing, inference in general is all wrapped in one specific Python package. It allows you to switch between SigLIP full or just the SigLIP text and image encoder, and the same goes for CLIP. So the API will automatically switch between a cosine similarity scenario with CLIP to a with a softmax activation to a SigLIP sigmoid activation with a full forward pass, depending on the type that you give it. I've also included manual downloads for SigLIP 384, floating point 16, clip, and we'll have quantized versions soon. And any other variants that come on the scene, I'll do my best to get them in this repo, and we'll just keep kind of staying on the cutting edge or on the edge of knowledge, which I love to be at. So let's look at a quick demo that I've attached a Gradio app. It's available in the repo as well. Just install the requirements and run app.py, and you'll find it at your local host. But I have it running here, and I've got a picture. Some of you might be familiar with this from Interstellar. And I just want to show you how quick it runs with the faster optimized graph. Like I said, it will be faster as we move forward with the quantized models. And it has the ability to run fast on a CPU and a GPU. So I'm going to submit a bunch of descriptions, and we'll see what happens. So fairly fast. It does a pretty good job. You'll notice, first of all, that all these percentages don't sum to 100%. The reason for that is that each one of these is a confidence for the image and the description pairwise. So, like I said, with clip, you've got that kind of softmax sum up to 1. That's not the case here. We had the innovation with Google was that was to bring in that kind of sigmoid loss. I believe you can put a softmax activation on the front, but I'm staying true to the scenario here. You'll notice what's really cool about SigLIP is that the more complex a description you give it, the higher its confidence in terms of the scenario. So it's definitely not Christopher Nolan. It does pretty well with a photo of a sad man in dungarees with short hair. But if I give it a full description of a scene, we're getting really close to a really kind of high confidence threshold here. Obviously, this is just a static image. What I can envision here is what we're all seeing out there in the world right now, things like RAG applications, ChromaDB. So imagine if we had a bunch of images all converted to fast CUDA accelerated vector representations, and then we plugged in SigLIP as a kind of fast optimized deployment. We could have a really quick kind of image vector database search framework for retail or for cataloging or for libraries or all of these different contexts that you can think of. So do have a play around, see what else you can pull with different images. It's just a matter of just dragging and dropping into the image here, or just like rerunning as you go. Something I've also included in the repo is a full kind of installation and run through of the APIs that are available. So we have, like I said, an inference scenario where it just all you need is images and text context. So it's as simple as just running with your model of choice here. So I'm running with clip once I've run this manual version here. So we've got an image of a dog, and I've added a little bit of complexity to it with the flowers and the grass because I want to see if I can full clip or SigLIP as well. With the inference mode, with the inference method, it takes care of the text and image encoder. It's just a matter of just sending a batch of images or a batch of contexts. And what I mean by that is it's capable of taking a dictionary of different scenarios. So whether it's a 2 classification scenarios or 5 classification scenarios, or a situational, or a color classification and an object classification scenario, it will take all of those, it will infer all of those different scenarios, and you'll get a dictionary of probabilities based on these specific keys. So a kind of convenience method for you all. What I plan to do with SigLIP full is to split into 3 models as well, so you can basically have the text encodings done beforehand without having to have it in the full forward pass every single time, so it's even more optimized. So you can imagine you can instantiate every single one of your contexts ahead of time and then just bring in new images for those rationalizations as you go. And again, if I switch to SigLIP full, I don't think anyone's got a full SigLIP ONNX framework or pipeline going yet. I know there's there's conversion available in the Hugging Face libraries and transformers. And you'll notice in this library, there's also the tokenization, and the pre-processing is still bound to Hugging Face. In a future update, it'll be fully NumPy, so it's just fully optimized, and you can run it on robots and so on with like a kind of low dependency footprint. But again, take a look with SigLIP full. We don't sum properly to 1. It's just the confidence for that specific scenario. And I've deliberately given it context with blue flowers and yellow flowers. So foot of dog, it doesn't do too good. It's, you know, better than a space scenario. But if I had blue flowers laying on grass, it does really well. But what's really cool about these zero-shot classification models is that I can try and fool it and it doesn't fall for it. So if I add it a brown and white dog laying on the grass with yellow flowers, it drops its confidence. So quite a lot of this context does match, but it's able to kind of bend and drop its confidence accordingly. And switching back to classic clip then is as simple as doing this. So I've made it as easy as I can for you all. As you can see, we've got a bunch of EP errors for retrying. I'm going to try and take care of that ahead of time for you guys. So instead of bringing it into the forward pass, we'll check what EPs are available first beforehand. But you know, one developer, lots of updates to do. You can also run a manual mode if you need as well. So if you need to extract the images separately, or if you want to do your cosine similarity as a kind of analytical project, it's available for you there. This is SigLIP and clip. And the great thing about the SigLIP kind of usage is that you have the pulled, flattened embedding available to you, but you also have the hidden output beforehand. So if you want to do things like bring in the saliency maps or the attention maps and starting to think about pipelines that involve those or visualizing those scenarios, then we're going to build that into this framework. And the idea ahead of the or down the path is that you'll notice in the repo, I have SAM ONNX available to you all as well. It's available and it's running and you can instantiate it, but it's not built into this full pipeline yet. The whole idea is to have, like I was mentioning earlier, the attention maps then feed into multi-point prompts for segment anything, which segment anything was another Facebook foundation model that was created, which basically has the ability to segment anything based on point-based prompts or bounding box prompts. What I'm really interested in doing is, and you've seen a lot of projects out there, is taking the multimodal scenario, like the descriptive scenario or the hierarchy of an image, and feeding that into a powerful foundational segmentation model. I've seen a lot of projects out there that just use Torch. What I want to do is bring all of this to Open Neural Network Exchange, and then down the line bring it to TensorRT, which is an NVIDIA framework for further optimization with GPUs, bringing it down to kind of low-level CUDA. So stay tuned for all of that. You've got all your manual downloads here. You've got a bunch of descriptions for how to run Gradio. And again, stay tuned for ultra-fast vector search as I go. If anything usurps SigLIP, or if anything like faster SAM or all of these different foundational variants out there come out and are available for ONNX and TensorRT, they will end up in this repo. So give me a shout if you want to collaborate. Give me a star. Give me a fork. I want to see what you're all up to. I'm going to put this in the description, and I'll speak to you all soon. And stay tuned for a video of Mr. B. He's this big, scary, ambitious thing, which has an AGX Xavier involved. I'm excited to see to show you all where he's gone in the last 5 years. I had to kind of put him to the side a bit, running the kind of the startup kind of race for a bit, but I'm looking to get back up there, and I'm looking to kind of get him doing some really cool things again. So I'll speak to you all soon, and have a good day.